Hello everyone, in this video we're going to learn about the torque equation of DC motor. What's in it for you are, first we will see what is torque, and next the torque equation of DC motor, and then we will see what is armature torque, and finally the shaft torque. And first, what is torque? A twisting or turning force about an axis on an object is known as torque. Torque equation of DC motor. Consider the armature of the motor. Let T be the torque on the armature, and R be the radius of armature in meters. F be the circumferential force on armature in newtons. N is speed of armature in RPM, and which is given by N by 60 in seconds. And the angular speed of armature is given by 2 pi N by 60 radian per second. Now the work done in one revolution is force into distance travelled in one revolution. That is F into 2 pi R joules. And the power developed P equals work done by time. And the time taken for one revolution is 60 by N. On substituting the values of work done and time on P, we get P equals F into R into 2 pi N by 60. From the diagram of armature, the mathematical equation for torque can be written as T equals F into R. And the angular speed of armature omega is 2 pi N by 60. Therefore, the power developed P equals T into omega. Next, the armature torque. Let TA be the gross torque developed by the armature in the motor. It is also called as total armature torques. From the power equation of DC motor, the gross mechanical power developed in armature is EBIA. So if the speed of the motor is n RPM, then the power in armature is gross armature torque into omega. That is EBIA equals TA into 2 pi N by 60. And we know that back EMF EB equals pi PNZ by 60A. On substituting EB and simplifying the equation, we get the total torque on armature TA equals 1 by 2 pi into pi IA into PZ by A. Or it can be written as TA equals 0.159 into pi IA into PZ by A Newton meter. Until now we have derived the equation of total torque produced on the armature, but practically the mechanical power developed in the armature is transmitted to the load through the shaft of the motor. Also, it is impossible to transmit the entire power developed by the armature to the load. This is because while transmitting the power to the shaft, there is a power loss due to friction, windage and iron loss. And the torque required to overcome this loss is called loss torque, and it is denoted by TL. These losses are also called as stray losses of the motor. Shaft torque. The actual torque available at the motor shaft for driving the mechanical equipment is known as shaft torque. In DC motor, the actual torque available at the shaft for doing useful work is known as shaft torque, and it is denoted as TSH. And the relation between power and torque is given by P equals 2 pi N TSH. Here P is power, N is speed in RPS, and TSH is shaft torque. And here is the formula for shaft torque. On simplifying this, we get TSH equals power by 2 pi N divided by 60 Newton meter. Therefore, we can say armature torque is equal to loss torque plus shaft torque. That is TA equals TL plus TSH. That is, the actual torque is the sum of both loss torque in the shaft due to losses and output torque available from the shaft of the motor. Now the speed of this motor remains the same all along the shaft, says RPM. Then the product of shaft torque and the angular speed omega is called the power available at the shaft. That is the net output of the motor. The maximum power a motor can deliver to the load is called output rating of a motor. It is generally expressed in horsepower. Therefore, the net power output of a motor P out is equal to shaft torque into angular speed omega. Now at no load condition, there is no load connected to the shaft. Hence, no shaft torque TSH is produced. Therefore, at no load condition, motor keeps on rotating at the speed of n RPM with armature torque TA. So, the armature torque has to satisfy only the loss torque due to friction and windage losses. The total torque TA developed in the armature of the motor is not available at the shaft because part of it is lost in overcoming the iron and friction losses in the motor. Therefore, the shaft torque TSH is somewhat less than the armature torque TA. The difference between TA and TSH is called loss torque. If the speed of the motor is n RPM, then the output of the shaft power in watts of the DC motor is given by PSH equals 2 pi N TSH divided by 60. And TSH equals output in watts divided by 2 pi N divided by 60 in Newton meters. On simplifying this, we get TSH equals 60 by 2 pi into output in watts divided by N. And we know that 60 by 2 pi equals 9.55. On substituting the value, we get TSH as 9.55 into output in watts divided by N Newton meters. And this is the formula for TSH.